Assalamualaikum. Welcome back to Circuit Lab Physics video tutorial for high school students. This episode is a revised excerpt of a past upload on selected key concepts in mechanics. We analyzed three hot multiple choice questions on acceleration, impulse, momentum, and impulsive force. So join me till the end of this video. Just stick around, watch and learn. Question number 1. If the magnitude of velocity is changing, what else is or are necessarily changing? One or more answers. Option letter A, acceleration. Option letter B, momentum. Option letter C, impulse. And option letter D, kinetic energy. And the correct answers are option B and option D, momentum and kinetic energy. Acceleration is defined as a change in velocity over a change in time. There is change in velocity delta v if the magnitude of the velocity increases or decreases with no change in direction. There's also change in velocity if only the direction changes without a change in the magnitude of the velocity, and if both the direction and the magnitude of the velocity changes. However, acceleration may be either constant or changing depending on the total or net force that causes the acceleration. Based on Newton's second law, if the net force is constant, then the acceleration is also constant. But if the net force is changing, then the acceleration is also changing. Just because the velocity is changing, it doesn't necessarily follow that the acceleration is also changing. That's why option A is considered incorrect. Option B, or momentum, is definitely correct. If the velocity changes, the momentum also changes. All right? And since um, change in momentum is also equal to impulse, the product of the force and the time of contact, or F times t, is what we call the impulse that is imparted on the body. And that is equal to the product of the mass and the change in the velocity or the change in momentum. That is why uh, option letter B is considered correct, but option letter C, or impulse, is not considered correct. All right? Because just like acceleration, impulse also depends on the total or the net force that's acting on the body, right? So if the net force or total force acting on the body is constant, then the impulse must also be constant. All right? Even if uh, the velocity is changing, it doesn't always follow that the impulse must also be changing. Not really, because the impulse depends on the net force. So if the net force is changing, then it follows that the impulse is also changing. All right? And lastly, for kinetic energy, since kinetic energy is equal to 1/2 mass times the square of the speed, all right? So if there's a change in the magnitude of velocity, or um, there is a change in the speed, all right, either the speed is increasing or decreasing, therefore it follows that the kinetic energy of the body must also be changing. Thus, option letter D, kinetic energy, is also considered correct. Question number 2. A high-speed plane and an innocent bird had a head-on collision. Question is, which of the following quantities would be equal for the airplane and the bird? One or more answers. Option letter A, force of impact. Option letter B, the change in momentum. Option letter C, impulse. And option letter D, acceleration just after the impact. Our correct answers are option A, option B, and option C. Force of impact, change in momentum, and the impulse are all the same for the plane and the bird. The force of impact, capital F, is given as a change in momentum divided by the uh, time of interaction delta t. All right. So the product of the mass and the change in the velocity is also known as the change in momentum. And if you divide that by the change in the time of contact or delta t, then we are expressing the force of impact, all right, uh, that will be exerted on the two bodies that are interacting, right? And since according to the third law of Newton, the law of interaction, the force that is exerted by the plane of the bird is just equal and opposite to the force exerted by the bird on the plane. All right? So it follows that the bird and the plane will be experiencing the same magnitude of the force of impact. That's why option letter A is considered correct. Now, the product of force and the time of contact, or F times delta t, is also known as impulse. And since impulse is also equal to the change in the momentum, delta p, or the mass times the change in the velocity, delta v, right? The fact that the force of impact is the same for both the plane and the bird, then it follows that both the impulse and the change in momentum of the two bodies are also equal, right? And for the acceleration after the impact, we say that based on Newton's second law, the acceleration is defined as the amount of the net force divided by the mass of the body. All right. We already said that the amount of force that the bird experiences is just equal to the amount of force that the bird exerts on the plane. All right. But since the mass of the bird is relatively very small, right? So the force that it experiences during the impact, all right, when that force is divided by a very small amount of mass, then we have a relatively large acceleration. So this is the case for the bird. The bird's mass is much, much smaller than the mass of the plane. So for the same amount of force, all right, but with a very small amount of mass, then the resulting acceleration, that is, the acceleration of the bird just after the impact, is also relatively greater compared to the acceleration that the airplane experiences, right? Uh, in as much as the mass of the airplane is extremely larger than the mass of the bird, even if the force of impact is the same, all right? Then the resulting acceleration for the airplane is a lot smaller, all right? In fact, it can hardly be noticed, all right? This is all in accordance with Newton's second law of motion, the law of acceleration. Our last question, question number 3. Frontman jumps from the roof of a tall building, but no injury occurs because the man lands on a large air-filled bag. No injury occurs because the bag, option letter A, provides the necessary force to stop the stuntman. Option letter B reduces the impulse imparted to the stuntman. Option letter C increases the time of impact and reduces the force on the stuntman. And option D increases the time of impact and reduces the impulse imparted to the stuntman. The correct answer is option letter C. No injury occurs because the bag increases the time of impact and reduces the force on the stuntman. The force of impact, capital F, is given as the change in momentum divided by the time of interaction, or F equals m delta b divided by delta t. We base this equation from the fact that impulse is equal to change in momentum. Obviously, the impact force is inversely proportional to the time of interaction, delta t. That means for the same mass and the same velocity change, or we may also say for the same change in momentum, the shorter the time delta t, the larger is the impact force. And the longer the time of interaction between the air-filled bag and the stuntman, the less is the impact force. Therefore, our answer to this question is, of course, option letter C. That is, no injury occurs on the stuntman because the bug increases the time of impact and thereby reduces the force on the stuntman. So that concludes our video lesson for this topic. Till the next episode, mabuhay, mashallah. Thank you very much. Alhamdulillah. Please follow me in my Facebook page, Watch and Learn. And please don't forget to subscribe to my YouTube channel.